Okay, the diagram below shows a sketch of the curve with equation y equals x minus 1, x minus 3, x plus 2. Calculate the total area of the two shaded regions. Okay, now it's 3 brackets this time, okay? And when you've got 3 brackets, it represents a cubic equation, okay? A cubic curve. In other words, this curve starts off with being x cubed, okay? Not x squared, it's x cubed. So you haven't got like a smiley face, you've got this shaped curve here, okay? And you can realize it's x cubed if you expand all these brackets. And we're going to have to do that, aren't we? If we think about it, because when we integrate, we're going to have to actually expand all that, okay? Let's not worry about it for a minute. Let's of course work out these values here, okay, where it cuts the x-axis. Okay, we need 3 values, and we're going to get that, aren't we, from here. Okay, so we can say, look, if you want to call this A, B, and C, you can. It's your choice. So you could say, look, at A, B, and C. Okay, you don't have to call them A, B, and C. The main thing is that you state that the curve cuts the x-axis, okay, at 3 points, and y will equal 0 there. So the A, B, and C, okay, the curve cuts the x-axis, okay, therefore y is equal to 0 at these points. So if you've got this here, we could say, look, x minus 1, x minus 3, x plus 2 is equal to 0. So when you've got 3 brackets times together equals 0, it's exactly the same process as we have when we've got 2 brackets with a quadratic, because you've got this times this equals 0. That means either one of them is equal to 0. So either that is 0, or the second bracket is 0, or the third bracket is 0. So that means x will equal to 1, or x will equal to 3, or x will equal to minus 2. Okay, so there you've got your A, B, and C values there. So your A is minus 2, 0, your B is 1, 0, your C is 3, 0. Okay, so if we know these values, minus 2, 1, 3, we need to go about then working up the area using definite integrals. But take note of the question here, it's quite clear, isn't it? It says calculate the total area of the 2 shaded regions. We need to do these, think of these as 2 separate regions, okay? So we can call this, say, area 1, okay, A1, and we can call this area 2. We have to do them separately, okay? You cannot do this all in one go, because if you do, it'll go wrong, and you perhaps will see at the end why, okay? So we need now to integrate and work out the area. So let's work out A1 first, okay? Right, and that will be the area and the curve here between minus 2 and 1, okay? So between minus 2 and 1, okay, from A to B, of this here. So x minus 1, x minus 3, x plus 2 dx, okay? Of course, I discussed earlier, in order to now integrate this, we're going to have to expand these brackets, okay? So there's a little bit of work here. So what we're going to need to do is FOIL, okay, on this. Well, I say FOIL, we need to do FOIL on a pair of them, yeah? And then we're going to need to do FOIL again, okay? So what I like to do is, when I multiply 3 brackets, I like to keep the first bracket as it is, and I like to multiply these here, okay? So I'm going to have x times x, which is x squared. So let's multiply this pair first. X times x is x squared. X times 2 is 2x. Minus 3 times x is minus 3x. And minus 3 times 2 is minus 6. Okay. Right. Then, okay, of course we're going to multiply by the first bracket as well, but before then, let's make this a bit tidier, yeah? Okay, so we've got x minus 1, okay, and then tidy this up, x squared, 2x take away 3x is minus x, okay, minus 6 dx. Okay, so we've got these brackets then times together. Okay, so I say the idea of FOIL, it doesn't quite work, doesn't it, when you've got three terms in there, but it's the same sort of principle now to expand these. Okay, so what you do is, of course, the way I do it is I focus on the first term there, the x, and then multiply that by every term in here. So I'm going to do x times x squared, which is x cubed, yeah? X times x squared is x cubed. X times minus x is minus x squared. X times minus 6 is minus 6x. Okay. We'll then focus on the minus 1. Okay. And we're going to do minus 1 times x squared is minus 1x squared, minus x squared. And then minus 1 times minus x. Okay, well, minus times a minus is a plus. And then minus 1 times minus 6. Minus times a minus is a plus. So we get that there. Okay, so we're almost at a stage where we can integrate. Okay, so let's simplify this. So we've got x cubed minus x squared and minus x squared can go together. So it'll be minus 2x squared. Minus 6x plus x is minus 5x. Minus 6 plus 1 is minus 5, and then plus 6 on the end. So there you go, right? There's your cubic. That's the actual equation of the curve when you've expanded the bracket from here to here. Okay, so quite a bit of work involved here to do that, okay? But that's what's needed, because we have to get it into this form in order to integrate it. So I'll pause the video now, and then we'll look at next video how to integrate this, and then how to deal with A2, and then how to find the total, okay, area of the two regions.